Hello everyone, good morning. Sorry not to be there. I make this presentation as my responsibility to patient chapter 19, and actually I really like this course but I cannot be there. So let's restart. Uh, my presentations about chapter 19 is about selection of appropriate statistical method, integration of design and analysis. Okay, let's continue to the next slide. Okay, before we start for chapter 19, to select appropriate statistic, we have to know something like general knowledge to understand about this chapter. The first is independent variable. Independent variable, I think you already know, consists of active independent variable like educational treatment or teaching method, and the second is attribute independent variable is level of parental education, social economic status, gender, age, ethnic group, IQ, or personality character. It's attribute of participant. And the next is dependent variable. It's also called outcome variable. In example for education is test score or questionnaire results. For research approach, it is consists of three research approach: the experimental approach, the non-experimental approach, and the descriptive approach. Okay, you can read in chapter 4, page 56. Okay, next slide. It's design classification. The general design classification consists of between group, within subject, and mixed design. Design classification of specific design consists of three: design for quasi-experimental design, quasi-experimental design, and random experimental design. You can read in chapter 4, page 56, but I want to make intention for what the meaning of quasi-experimental design and randomized experimental design. The reason the name is quasi and randoms, it's because quasi not take a sample by random, but random experimental design take a sample or decided sample by random sample. Okay, the next you already know scale of level or level of measurement. It consists of four scale: nominal like unordered scale or mark scale, yes, no, X, female or male, or it can be more than two, and ordinal range scale, ratio, and interval data. It's very important for inferential statistic. The level of measurement are essential to fulfill the statistic definition, like to use differential statistic, because it's important to decide your statistic is fulfill assumption or not fulfill. In this book, the meaning it's you not feel like the assumption or feel doing a violation of assumption. It's important in the part of the homogeneity and normal distribution. Okay, this is the schematic diagram showing how the general type of statistic and hypothesis question used in the study correspond to the purpose and the approach. Okay, we start from the general purpose. It consists of two as per relation between variable and description. For general approach, it consists of two: experimental active independent variable and non-experimental attribute independent variable. I already make a explanation for active and attribute independent variable. For specific approach, it consists of 5: randomized experimental, quasi-experimental, comparative, associative, and descriptive. Specific purpose is determine cause, examine cause for quasi-experimental, comparative, compare group. Examine causality is mean the cause and effect, something like that. Association, find association and make prediction. Descriptive statistic for summarize data. For association, maybe it's can be a positive relation for the ratio or negative relation. Positive relations means that if the other variable is high, the another variable high as well. But for negative relation is something like if the one variable is high and the another variable is low, it's mean negative relation. Type of question: diver is mean to compare group. Associational is to relate variable to know correlation between a variable or relation between variable, and descriptive to describe the result or to summarize the data. General type of the statistic is mean kind of the test. For difference of compare group, you can doing t-test, ANOVA, Whitney, Wilcoxon, and the other. For associational inferential statistic, you can correlation, multiple regression, something like. For non-parametric is like McNamara, Person, and Kendall-Tau. For descriptive statistic, you can do like histogram, means, percentage, and if you want to make a comprehend description for the data, you can using RAS model because it's very contemporary for descriptive statistic. Okay, next. Okay, actually, my job is to help you to understand four figure here. Figure for 19.3, 19.4, 19.5, and 19.6. But I want to explain this picture first. This feature or this picture is a decision tree to decide how to select appropriate statistic. The first box is what type of research question. There are many more, 5 or more than 5, or the level of independent variable. If you have more than 5 or the level of independent variable according to the research question, you have to choose yes. So you have to choose the box for associational question related variable. But if no, you can choose different question for compare group. It doesn't mean if you just yes, you just can doing like associational analysis. Not you can doing a something like more than that. You can do descriptive as well. Okay. Let's start for if you choose yes is there more than one independent variable, you can choose the feature for 19.4 and 19.6. 19.4 and 19.6. But if you choose no, and is there more than one independent or dependent variable? If yes, you can choose figure 19.5. If no, you can choose 19.3. Yeah, I have to help you to understand four figure in this chapter. Figure 19.3 is basic difference statistic. Figure 19.5 is complex difference statistic. It's like more complex like ANOVA, something like that. And figure 19.4 is basic associational statistic. It's like person Kendall tall test and the other. And for the figure and 19.6, it's complex associational statistic. It's like ANOVA, Markova, ANOVA two-way or something like that. Okay, let's do. This is the explanation for the previous image or picture. Okay, let me start. For the figure 19.3, page 340. This is basic difference statistic or the compare group analysis. Okay. For the basic difference statistic, it's consists to parametric statistic and non-parametric statistic. Actually, parametric statistic and non-parametric statistic is decided according to your data. You have to choose parametric statistic or non-parametric statistic, which I learned before in my master degree. People call it inferential statistic, consists of parametric statistic and non-parametric statistic. Okay. We will learn the first column in here. It's scale of measurement of dependent variable. To use parametric statistic, you have to fulfill all of the assumption, or it's mean assumption no mark failure. It's mean you have to dependent variable and normal distribution data, and for some case you have to fulfill the homogeneity of variance. You can using Levin statistic, but for normal distribution data, you can use in SPSS as well, like Shapiro-Wilk test or Kolmogorov-Smirnov test to know normal distribution curve or data. And the other is non-parametric statistic. It's dependent variable as well. Clearly ordinal rank data or assumption not fulfill the assumption or assumption mark failed. It's mean you have a data and the data is not distributed normally or didn't have a normal distribution, you can have parametric statistic. And dependent variable, for dependent variable, it's nominal. Look at this column first before we continue for the others. It's mean that in parametric statistic, you can do parametric statistic if you have two scale of data. Do you realize you can doing parametric statistic if you have a ratio scale or interval scale? But if you have ordinal or nominal scale, you doesn't need doing something like parametric statistic. But if you have ordinal and nominal, you just do non-parametric statistic. So the scale of data is very important in before choosing parametric and non-parametric statistic. Okay, next to the next column, it's what is compared in this test. It's for parametric statistic is mean of the test. For the non-parametric median or rank, or for nominal data is count. Okay, we have two big column here. One factor or independent variable with two categories of level. is one independent variable, is more categories or level, is more it's simply if you have more than 3 group experiment you can choose this. But if you just have two categories or two group, you can choose decide. Okay, it's interesting to explain between and within. Between in this table mean independent sample of the what the meaning of independent sample. Independent sample it's mean sample not have relation with each other. It's mean that if you have a two group, one is done by pre-test and post-test, and the another one is, I mean, the experiment or control group is done how pre-test and post-test. The independent sample is the result. I mean, the independent sample is uh, the treatment. No. Independent sample is the result of the post-test 1 and post-test 2. But for the repeat measure or related sample, it's mean that within group. Within group, it's mean you have one experimental design. It's doing pre-test and post-test, and the related sample is post-test result and pre-test results. Okay, if you have independent sample, it's between the groups. You for the parametric statistic you can doing t-test or one-way ANOVA. For non-parametric you can doing Ullmann-Whitney, and for nominal data you can doing chi-square or Fisher-Exas test. For the related sample, for parametric, you can doing paired sample t-test. You can know from this t-test consists of two kinds of tests: independent sample test and paired sample test is called according to the related sample or independent sample. For non-parametric, if the data is ordinal, you can doing Wilcoxon or sign test. But if the non-parametric data is nominal, you can doing McNemar. For parametric statistic, for more than two independent variable, more than it's mean more than two independent variable, more than three group, I think you can one-way ANOVA use parametric or repeated measure ANOVA or maybe ANOVA 2. For non-parametric, you can cross Wallis test, and for related sample, you can do Friedman test. For nominal data, you can chi-square, and for the related sample, you can doing Cochrane key test, and independent sample chi-square test. So this is the table. Just at the table, you have to practice to doing analysis using all of this kind of the test. You have to learn SPSS because all of the menu, or all of the test is included or involved in SPSS menu. You can doing parametric test or non-parametric test in SPSS. But the important point is in here. If you have interval and ratio data, and after the normal distribution test, it show normal curve or normal data, and you doing homogeneity test before doing ANOVA because it's important and it show that your data is homogeneous, you can doing a parametric statistic. But it's not fulfill assumption or data just nominal or ordinal, you just can do non-parametric statistic. It's important point in this table. Okay, let's we next for the next table. Okay, this figure is basic additional statistic. It's mean to relate one variable with another variable. For this basic difference statistic, it's to compare one variable and the another variable. For this picture 19.4, it's basic associational statistic is to make a auto-no relation between the other variable. Okay, we start for this column. This column is level scale of measurement variable of both normal data and other assumption is not marked violet. And the next one is both variable at least ordinal data, and one or both variable are nominal data. It's mean that for basic associational statistics, the assumption for just for ordinal and nominal data. If we it's for focus is for the scale force. Scale consists of ordinal data, nominal data, and normal data. It's mean that not nominal data. It's mean that interval data or ratio data after normal assumption or normal distribution test using Kolmogorov, Smirnov, or Shapiro-Wilk. Okay. I will repeat for this column. Variable or both normal data is fulfill normal assumption, and the other assumption not marked violet is mean fulfill the another assumption like homogenic, different, or dependent variable, or depend variable. Depend variable is mean that your item not related. I mean your variable doesn't have effect for the another variable. Okay, it's related. For this is score. Score can be test score, questionnaire score, or both variable related rank. It's for nominal data. It's count. It's the for this column. It's kind of your test. You can learn this test in chapter 21 and 22. For the first row here, if your data is normal and fulfill all of the assumption, you to know the relation, correlation, or associational analysis of to doing associational analysis, you can do Poisson error or bivariate regression. If both variable is ordinal, you can doing Spearman or Kendall here, and is one or both variable are nominal. It's mean that if you have a nominal data, or ordinal data and nominal data, you can doing for p-test or Chamorro test. Okay, we will continue for the next picture or next feature. This is complex difference statistic. Complex difference statistic. We start for here. Dependent variable. The complex difference statistic according to dependent variable. If your dependent variable is normal distributed and depend variable is mean that which I explained before doesn't affect another variable. The second row here is ordinal dependent variable is nominal, several normally distributed dependent variables. It means that if you have a more dependent variable, I mean more test scores, more than 2 questionnaire, or more than 2 test score, and some of the data is not distributed normally, you can doing test for this row. Okay, I will start from here too. It's one normally distributed dependent variable. You have some dependent variable, just is one normal. So you're doing this row for the test. For all between the group, it's factorial ANOVA. For all within subject, you can factorial ANOVA with repeat measurement on all focus. And for mix between and within, you can doing factorial ANOVA with repeat measure on last or last two factor. For ordinal dependent variable is not fulfill the normal distribution, you can non-common. The meaning of non-common, I make a note here. Non-common ordinal statistics are equivalent to the factorial ANOVA. For nominal dependent variable, you can do log linear. For between group, all within subject is non-common, and non-common is you can use factorial ANOVA. For log linear is something seen in the literature but is not discussed in this book. It's similar to factorial ANOVA for nominal categorical data. And I think it's like complex chi-square for log linear. But if you have a data more than 2 and several normally distributed and dependent variable, you can use MANOVA with repeat measure on all focus, MANOVA with repeat measure on last or last several factor. Okay, it's the complex difference statistic. It's meant to compare group. If you 2 or more independent variable, it's mean that if you have 2, you at least you can do ANOVA for the complex statistic, but ANOVA it's also included in basic difference statistic as well. But some people which expert in the statistic use complex difference statistic like MANOVA and ANCOVA and MANOVA 2-way or ANOVA 2-way. You can check in the statistical book or SPSS book. Okay, I think it's the last figure. It's figure 19.6. It's complex associational statistic. It's you have one dependent variable to several independent variable. It's normally distributed, continuous, and dichotomous. Sometimes it's normal distribution. It means that you have not ordinal. It's ratio or interval data. For dichotomous, sometimes it can be nominal, unordered level. Sometimes can be ordered level or ordinal. But dichotomous is more than same like yes or no, of female or male but it's caught by 1 and 2, and misconception and no misconception it's caught by 1 and 2. It's dichotomous data. It's dichotomous. Okay, if one dependent variable but several independent variables are normally distributed, you can use multiple regression for continuous data. But for this dichotomous data, you can doing discriminant analysis. But if some normal or some dichotomous, I mean it's not fully normal distributed, you can doing multiple regression as well. For dichotomies, you can doing logistic regression. For all dichotomous, I mean several independent variable, all dichotomous, and one dependent variable and is continuous. You can doing multiple regression. And for the all dichotomous variable is for several independent, and the other for one dependent variable is dichotomous as well. You can doing logistic regression. But if you want to doing I mean the modern analysis for the complex associational statistic, you can learn about some factorial analysis, or you can doing something like PLS, WAP PLS, or Smart PLS. You can download free application for that software, and you can get the free tutorial and the book for the same and PLS in the internet. But according to my opinion, uh, using multiple regression is for the data is not popular in article in journal. Some article using more prefer to using something like SIME or PLS analysis. Okay, uh, this is all of my presentation. I just want to say thank you and sorry for everything not to be there.